Hello and welcome everyone. In this video tutorial, we will discuss about the concept of deadlocks of threads and how we can avoid deadlocks in Python, and we will discuss examples related to both of these topics. So without any further delay, let's start with the very first topic and let's understand what is a deadlock of threads. So basically, when multiple threads are waiting on a condition that never comes true, this is known as a deadlock. Now this deadlock is a form of concurrency failure. We can understand this whole thing with the help of an example which is also represented on the screen. So for instance, there are two threads T1 and T2. The T1 thread is waiting for the release of lock 1, which is held by the thread T2 before releasing the lock L1, but the T2 thread does the same thing and it is waiting for the release of lock 2, and it is waiting to release the lock 2 when the thread 1 will release the lock 1. So basically this type of situation happens when both the threads are waiting for each other. So as a result of a deadlock, threads cannot move forward and the program stuck or stopped and needed to be forcefully terminated. Deadlocks are an unexpected side effect or defect in our concurrent programming. They are not created on purpose. Still, we can run into a deadlock situation in variety of ways. Here are some common typical examples related to threading deadlock. Very first one is a self-referential thread, basically a thread that waits for itself. Then there are threads that rely on one another, whose example we have seen just before. After this, when a thread is unable to release a resource, it is basically a deadlock only. And in the last, mutex locks acquired by threads in various sequences. Condition basically happens when we do not perform lock in a particular order. Now let us understand this whole deadlock thing with the help of an example. So here on the screen you can see one example. In this, what we have done, we imported the thread class from the threading module and we imported the current underscore thread function from it. So you know, the thread class is used to define a thread, and the current underscore thread function is used to get the current thread name. Then we define a function with name task, which takes a parameter other. Now what this whole task will do, it will wait for our main thread to get executed, and then we define another thread with name new thread, and we started it with by passing a main thread as an argument to it. So what here will happen, let me execute this and show you. Here you can see there is thread 5 which is waiting for the main thread to complete its execution, but on the other hand, main thread is also waiting for thread 5 to complete its execution. So this is one of the cases of deadlock. Both the threads are waiting for each other to complete its execution, but as both the threads are in the waiting condition, it means they are in a deadlock. Now we cannot complete this program, so what we need to do, we need to stop this terminal. For that, I will click on this kernel option and then I will restart and clear all outputs. So this was a basic example related to deadlock. Now let's move forward and let's discuss how we can avoid deadlock. The best strategy for preventing deadlocks in Python application is to make an effort to adhere to the standard practices of avoiding deadlock. So very first practice is about using the context manager while acquiring and releasing locks. Then the second best practice is to use timeouts whenever there is a waiting, and in the last, we should always acquire locks in the same order. So it means we need to maintain the lock ordering. Let us discuss each of this practice in more detail. So very first practice is about using the context manager. So manually acquiring locks involve the use of acquire at the start of the important section and then calling the release function at the conclusion. However, we should always ignore this approach and use the context manager, which helps to achieve the same thing by using less code. The advantage of using the context manager is that regardless of how the block exits, for example, the block exits normally or there is any exception or error, the lock is always released right away. So how we can use a context manager? Let us discuss this thing with the help of an example. So here you can see, this is an example from our previous tutorial only, where we implemented the increment function, which increments the value of x by the given value which is specified as an argument to this method. So in that condition, what we were doing, we were using the lock object and we were manually calling the acquire and the release method. But instead of doing that, here you can see we use this statement that is with lock, and all the code which should be there within our within the acquire and release method are specified in this code block of with. So if I execute this code block will get executed in the same manner as it was executed. But in this, we have used a best practice of using the context manager instead of manually calling the acquire and the release method. Now the next practice is about using the timeouts. The concurrency primitive calls may block frequently, but every blocking call made to the concurrent primitive accepts a timeout parameter, and if this concurrency primitive runs successfully, it will return true, else it will return false. So how we can define a timeout? Let us discuss that also. So here you can see we are simply using the same example of deadlock which we implemented earlier, but this time with the join method, which is a concurrency primitive, we have used this timeout parameter and we specified the value of timeout as 5. So whenever our program is in the waiting condition, after 5 seconds the execution will automatically end. So just like using the timeout with join method, we can use that with other primitives as well, for example acquire, and we can also use that with release method as well. Let me run this program. So here you can see it is in the waiting situation, but after 5 seconds this program will automatically end. And here you can see my cell has been executed. It means we have successfully, let me add one more statement to it so that we get to know that our program is executed. Let me do this, and once the waiting is over, we got this result, that is program executed. How we can use this timeout option with our concurrency primitives like acquire, join and release. Let's come back and let's discuss about the another best practice, that is lock ordering. So lock ordering is another best practice to overcome deadlock, and it has been done by acquiring locks in the same order throughout the application. This condition or practice is commonly known as lock ordering. A list of threading may be used in some applications to abstract acquisition of locks. Lock objects that can be iterated or called to a method that acquires the lock in a predictable order. In the event that this is not possible, you might need to audit your code to make sure that the potential pathways through it acquires the lock in the same sequence. So we have to maintain the sequence of our locks in the same order. That we are already doing throughout our example. And with this, we have come to the end of this tutorial session. I hope with this you got an idea related to deadlocks and how we can avoid deadlocks in Python. Thank you so much for watching this video. We will see you in the next one.